Greetings, Captain W here for round 2 of video lecture. The topic today is section 10.11, and what we're going to do is look at the hypothesis testing on proportions. So for proportions, what we're talking about, we're going to use the Greek letter pi, and that's going to represent our population proportion. And what we're going to be doing for the proportion, it is exactly what it says, a ratio between 0 and 1. Noting here the book uses little p, but we're going to stick with our Greek letters, our population statistics. And all that it is how much of something, how much of a random variable do we actually have? Do we have 25%? Do we have 50%? Do we have 100%? So it's a random variable. What we're going to be working with is the same old thing we've been doing before, the area under the curve. Hence it can go from 0 on up to 1. So the solution method is exactly the same as with our previous test, being that we're going to assume some hypothesis and then from that have an alternate hypothesis, and then go ahead and see whether or not our data supports rejecting that original hypothesis, our null hypothesis. So just to introduce us to our terms that we have, for our test in this case, we're going to have our proportion pi. That's our population proportion, the given data for some sample set. And in a minute, we're going to see, looking at this for the proportion of a color of M&Ms and comparing the proportion that we measure in a random sample to that's advertised as the global population, the global ratio. Just like before, if we have our null hypothesis, it can either be equal to, less than, or greater than, and then the alternate hypothesis would then be not equal to, greater than, or less than, i.e. a two-sided test or a one-sided test for the other ones. Like before, the little trick that if we have the case that we're testing to see if the alternative is greater than a value, that'll determine our alternate hypothesis, and then we'll go up and back out of that our null hypothesis of being less than or equal to. So our process is the same. Step 1 is our hypothesis. Now for our statistics, the only difference here is that we may have two different ways of getting that total area under the curve. And that could be whether or not we're going to do this as using the binomial tables, and that's an 8.1 that we used before, or if we get enough of a large sample size, we can actually approximate the binomial with the normal distribution. So we're going to walk through those two examples. So for our topic of the test statistics, what we're going to do is look at our actual data, because what we're shooting for is this proportion measurement here. That is the population proportion. Our data is going to give us our test proportion from our data, and we're going to treat our data as an experiment. Either it passes the experiment or it fails the experiment. So in this case, from our data set, we will use the random variable x to represent the number of data points that pass, that meet our criteria. Our total number of samples would be n, and that would give us our sample proportion here of little p. So in the case, the running case of the number of M&Ms, the scenario could be we want to count the number of green M&Ms out of a bag. So the bag may give us, say, 220 M&Ms. X would be our value of green, say 22 M&Ms. So our sample proportion would be the 22 over the 220. So that's our setup for data, and from this point we can just go ahead and manipulate that data and move forward. And what we're really going to do is look at our test from our sample proportion that we're going to get from our data and compare that to the population proportion of pi. And so we're really looking at this sample proportion versus that population proportion. Just as before, we can make use of table 8.1 to determine our cumulative probabilities, and that's the same data that we've done before. So in the case that we may get 22 green M&Ms, we could look at the chance of getting that 22 green M&Ms given the total of 220. Now this may not be the best example, because if you remember, our tables only go up to maybe 30 or so for values of n, and beyond that we do another trick. But the idea is the same. We can look at our tables in A1, and they're going to give us the area under the curve. And again, that's the cumulative area, everything from the probability of getting 0 green M&Ms on up to the value of R. That would be the number of M&Ms that we actually go ahead and get. These would be the ones that go ahead and pass our test. So that's our scenario when we have relatively small numbers of samples. Again, it's in table 8.1. And recall, using table 8.1, what we have is the cumulative probability distribution for a total number of n samples, and then the R is the probability of getting up to that number, so R of 0, 1, 2, and so on. The P aspect here, this P is actually the part of our test that we're doing. So recall, we're doing the test, say, that our population proportion is actually equal to a given value of our sample proportion. And this value of P0 would be what we'd be really using, looking up in our table of A1.